Okay, so let us start with solubility product. This is the last topic of this chapter. और नाम से ही I hope कि clear as it is related to solubility. So what is solubility? You know, saturated solution. In a saturated solution, the concentration of the ions, product of the concentration of the ions raised to the power their stoichiometric coefficients, and that product is called solubility product. For example, see, this is the general electrolyte, sparingly soluble salt, we can say. It is MXXY. So in this particular case, see, X moles of My positive and Y moles of X negative, they are present in the solution, because you know MXXY, it gives X moles of My positive and Y moles of X negative. So if solubility of this salt is S, small s, so out of one, let us say this is 1 mole initially, so out of 1 only S mole per liter of MXXY goes into the solution. Therefore, it is XS and YS. So the product of the concentration of these cation and anion raised to power their stoichiometric coefficients, that is called solubility product. So this see XX raised to power X, YS raised to power Y. By mistake it is written capital X, okay, they are small. So X raised to power X, Y raised to power Y into S raised to power X plus Y. So in this way, solubility is equal to Ksp divided by X raised to power X, Y raised to power Y, power 1 upon X plus Y. Let us say we have K4FeCN6. This is the salt. So we get 4K plus and FeCN6 4 negative. So if solubility of this salt is S, then what is the solubility product? So see, this becomes 4S, it becomes S. So Ksp of this salt is K plus raised to power 4 FeCN6 raised to power 4 negative, means FeCN6 4 negative raised to power 1. So it is 4S raised to power 4, S raised to power 1. It becomes 256, S raised to power 5. Now next is barium sulfate, saturated solution of barium sulfate. Initially let us say 1 mole of barium sulfate we have. At equilibrium, if S is the solubility, actually for sparingly soluble salts, solubility is very less. So 1 minus X is taken as 1 only. So solubility of barium 2 plus and sulfate, because 1 barium sulfate will give 1 mole of barium, 1 mole of sulfate. So it is S, this one is also S. So Ksp is S raised to power 2. And S is equal to square root of Ksp. Ag2SO4. So obviously if solubility is S, this becomes 2Ag plus and 1S. So Ksp of Ag2SO4 is Ag plus raised to power 2, sulfate raised to power 1. So 2S raised to power 2, S raised to power 1. So it becomes 4S cube. So S becomes cube root of Ksp by 4 cube root, or we can write it as 1 by 3. So what are the applications of solubility product? First is common ion effect on the solubility of salts. So if common ion is present, then solubility of the salts decreases. How is it possible? See, if we have like nickel hydroxide. So in nickel hydroxide, nickel hydroxide has nickel 2 plus ion and OH negative ions. If we add NaOH in the salt, it will give Na plus and OH negative. See, there is a common ion. So tell me, equilibrium किस साइड शिफ्ट होगा, फॉरवर्ड और बैकवर्ड? Yes, so equilibrium shifts backward. So that's why insoluble, this is insoluble form of nickel hydroxide, this is soluble form of nickel hydroxide. So insoluble form increases, that means soluble form decreases, and that's why solubility of the salts decreases by the addition of any common ion of that particular salt, and it follows Le Chatelier's principle that if product increases, equilibrium shifts backward. If product is decreased by any ion, then it will shift forward. Same vice versa for reactant. Now solubility of NaCl we have discussed. It can be decreased by addition of HCl, and that is used for the purification process of NaCl. Common ion effect also used in the estimation of sparingly soluble salt by using solubility product. Now application of solubility product. In the preparation of silver ion as silver chloride, ferric oxide and its hydroxide, barium ion as its sulfate, for quantitative estimation, this particular principle is used. What is the relation between ionic product and solubility product? If ionic product is greater than solubility product, then what happened? Hello? What do you mean by ionic product and what do you mean by solubility product? Let us say we have NaCl, Na plus aqueous, Cl negative aqueous. We write KIP, that is Na plus constant. See, is there any difference between these two? Ionic product is product of the concentration of the ions. KSP is also product of the concentration of the ions of the same salt. So basic difference is, this is the product of the concentration of the ion at saturation point. When we have saturated solution, at that time the product of the concentration of cation and anion raised to power their stoichiometric coefficient, that is called solubility product. At any concentration, see this is at a saturation point only, at any concentration, product of the concentration of the ions raised to power their stoichiometric coefficient, that is called ionic product. So ionic product is general term. This is general term, means solubility product is also ionic product, but it is at a saturation point. So this is actually specific term. Solubility product is a specific term, that it is the ionic product of the concentration of the ions at saturation point, in the saturated solution, when solution is saturated. That's why when ionic product is greater than solubility product, then that means ions are more, concentration of the ions is more than it is required to form a saturated solution. That means solution is super saturated. So in that case, precipitation takes place. Second, if ionic product is equal to solubility product, that means solution is saturated solution. But precipitation is yet to take place, because whenever ionic product becomes greater than solubility product, then precipitation takes place. If ionic product is less than solubility product, that means solution is unsaturated, more salt can be dissolved. So these are super saturated solutions. So concept of solubility product that helps in the predicting the formation of PPT, because in an unsaturated solution, ionic product is less than solubility product and therefore no precipitation takes place. But if in a super saturated solution, ionic product is greater than solubility product. Ionic product is greater than solubility product. And in a saturated solution, ionic product is equal to solubility product. Precipitation takes place, well, this is conditional precipitation, means there is no precipitation actually taking place, because the whole solution is, means now it is the maximum amount of the solute that can be dissolved in this particular amount of solvent. Then solubility of a salts of weak acids like phosphates increases at a lower pH, and it is useful in salting out of soap. You know, in what is soap? That is sodium or potassium salt. Sodium or potassium salt of higher fatty acid. So if we add NaCl into it, you know, there is a common ion effect. So equilibrium shifts backward. Yes, now this is the question. A weak acid H3A, means it is triprotic acid, has three dissociation constants K1, K2 and K3 in water, and value of K1 is 10 raised power minus 4, value of K2 is 10 raised power minus 8, and value of K3, that is 10 raised power minus 16. That means K1 is greater than K2. K2 is very, very greater than K3C, because from minus 10 to the minus 4 to 10 raised power minus 8, there is a, it is 10 raised power 4 times, but here it become 10 raised power 8 times. K2 is 10 raised power 8 times greater than 10 raised power means than K3. So this is the order. Now a metal M that forms salt Ma, which is sparingly soluble, and solubility product is given 10 raised power minus 30, means it is very less soluble salt in water. It forms a water soluble metal chloride, that is MCl3, which dissociates into M3 plus and Cl negative ions completely in aqueous solution. So MCl3 that gives M3 plus aqueous and 3Cl negative aqueous. MCl3 completely dissolve हो रहा है. That means MCl3 is in the form of M3 plus and 3Cl negative, means it is a strong electrolyte, we can say, क्योंकि यहाँ लिखा है ना, it forms a water soluble chloride, that is MCl3, which dissociates into M3 plus and Cl negative ions completely in aqueous solution. That's why I made this arrow. It is a strong electrolyte, or we can say it is a strong salt. Then for an aqueous solution of the acid H3A of concentration C, which is very close to 1 molar at room temperature, the correct statement is, first option is the acid acts as a dibasic acid. Say as per the dissociation constants, if we look at the dissociation constants, you know K1 is greater than K2 and K2 is very, very greater than K3. So we can say that it can act as a dibasic acid. We put it in hold. Next is H plus ion concentration in the solution is close to K1C raised to power half. So see, you know H3A, first it gives H plus and H2A negative, and its dissociation constant is 10 raised to power minus 4. Then H2A negative that give H plus and Ha2 negative, and its K value is 10 raised to power minus 8. Then Ha2 negative to give H plus and A3 negative, its K value is 10 raised to power minus 16. So let us start with concentration C of H3A. So when we have, let us say, initially it had concentration C, now at equilibrium, let us say X mole of H3A dissociates and it gives X. Now after getting this X amount, actually C is 1 only, na? So let us say take it as 1 only. So it becomes 1 minus X. So from here, you know, K1 is equal to H plus ion concentration, H2A negative ion concentration divided by H3A concentration. So K1 is 10 raised power minus 4. It is x divided by 1 minus x. But you know it is 10 raised power minus 4. मैंने बताया था कि 5% से कम हो, 5 into 10 raised power minus 2 से कम हो, then this x is neglected as compared to 1. That means x is very less than 1. So it becomes 10 raised power minus 4 equal to x square upon 1. So x is actually 10 raised to power minus 2. X is 10 raised power minus 2. That means now in the second step, H2A negative, we have only 10 raised to power minus 2. Initially it is 10 minus 2, then it is 0, 0. So now this 10 raised to power minus 2, 1 minus x. So it becomes 0.01. Sorry, let us take it as y. So it is 0.01 into y, 0.01 into y. But see the value of K2. It is 10 raised to power minus 8. So if we calculate, see from here, K2 is equal to H plus ion concentration, HA 2 negative ion concentration divided by H2A negative ion concentration. K2 is 10 raised power minus 8. H plus, it becomes 0.1y, 0.01y from this 0.01y from here, and plus x. What was x? 10 raised power minus 2 means 0.01, because total H plus ion from first step plus H plus ion from the second step. So it becomes 0.01y plus 0.01 into 0.01y divided by 0.01 into 1 minus y. But you know it is 10 raised to power minus I. That's why y is very less. So as compared to 0.01, 0.01 into y can be neglected. So here 10 raised power minus 8, it becomes 0.01 into 0.01 y divided by 0.01, because y is very less than 1. So it is cancelled. That means y comes out to be 10 raised to power minus 6. So that means, see here on the first step, H plus concentration is 10 raised to power minus 2. In the second step, H plus ion concentration comes out to be 10 raised to power minus 6. They are far less than this. So we consider first step is the main step to decide the H plus ion concentration and pH of the solution. So that means H plus ion concentration we can predict only from the first step. So that implies this step is the main step. ये जो मैंने कैलकुलेशन करी ना आपको, it is just to show you कि H plus ion from the second step is only 10 raised power minus, means this much amount is dissociated. So it becomes far less. Okay. So overall H plus ion concentration is 10 raised power minus 2 from the first step, and 0.01 into 10 raised power minus 6 means 10 raised power minus 8 from the second step. Only 10 raised power minus 8 from the second step, because this 0.01 is from the first step only. So it is only 0.01 into y. So y is 10 raised power minus 6 into 0.01. So it becomes 10 raised power minus 8 molar. So H3A, so this is C00. So C minus X, X, X. So that's why K1 is H plus ion concentration, H2A negative concentration by H3A concentration. So it becomes X into X divided by C minus X. So this C minus X is taken as C only. So X square upon C. So X square equal to K1 into C. So X is equal to square root of K1 into C, and that is H plus. Yes, C minus X is taken as C only, because value of K1 is 10 raised power minus 4 na. Come again.
So it should be C into 1 minus X.
Oh, I got it. You are saying like this.
Yes.
So actually C alpha I have taken as X. It is C alpha. I am not taking X as degree of dissociation. I am taking whole this as C X. This, okay, because there is no need to calculate degree of dissociation. That's why I took this X as C alpha, because otherwise first I calculate alpha, then C alpha, because alpha comes out to be under root K1 by C. From that relation, alpha comes out to be K1 over C. Then to calculate H plus ion, we have C alpha. So it comes out to be C into K1 by C. So it is K1 into C. Okay. So that's why I write it like this only, because I need to know in the second step H plus ion concentration only. There is no mention of degree of dissociation. Okay. That's why I took that whole part C alpha as a X. So it comes out to be K1 into C. That means second option is correct. First option is almost correct. Why is it so? Because first dissociation constant is 10 raised power minus 4. Second dissociation constant is 10 raised power minus 8. And third is least 10 raised to power minus 16. Means it is far, far less. That's why we can consider this weak acid as dibasic acid. Next is H plus concentration in the solution is, this is wrong, because we cannot take into account all the steps, because in the other steps H plus ion concentration is far less. Then next is on addition of excess of the soluble MCl3 to the acid solution, the H plus ion concentration in the solution will be 3C. Let us see. On addition of excess of soluble salt to the acid solution. See, we have H3A as the acid. So this acid will give H plus and H2A negative in the first step. H2A negative gives H plus and Ha2 negative in the second step, and the third step this Ha2 negative will give H plus and A3 negative, and you know K3 is very less. So if we add all the steps, H3A will give 3H plus A3 negative. This is only possible if all the steps are taking place one by one. So see, when we add this soluble salt MCl3 in the solution, so you know MCl3 gives M3 plus ion and 3 Cl negative ions. So what happened, you know, it is written above. Yes, MA. MA is a sparingly soluble salt and its solubility product is very less, 10 raised per minus 30. So what happened, when we add MCl3, we get M3 plus ions. So these M3 plus ions will start combining with A3 plus and leads to the formation of this insoluble salt Ma, which is sparingly soluble, which is solubility is very less. So this is going to be decreased by M3 plus ion. ये जो है A3 negative decrease होना शुरू होगा. So this equilibrium shifts forward. So when this equilibrium shifts forward, that will affect the concentration of Ha2 negative. So Ha2 negative concentration again goes on decreasing, and therefore that will affect H2A because that will go forward, and ultimately this H2A concentration decrease will shift this equilibrium forward, and in this way this whole process, this one, will go to completion when we add excess of, say we are adding excess of MCl3. So eventually what happened, all the A3 negative ion converted into Ma. So whole of the H3A is converted into 3H plus and A3 negative. That is the effect of and this ion M3 plus, and this is called, what is the name of this effect? It is not common ion effect. So what is the name of this effect? I told you, odd ion effect. An ion which is consuming the product. Common ion effect में क्या होता है? One of the product is common and therefore equilibrium shifts backward. But here one of the product is consumed by MCl3, M3 plus ion, and that's why equilibrium shifts forward. That make H3A to completely ionize into 3H plus, though it is very weak, but because A3 plus ions are consumed by M3 plus, so all the steps involved, they will lead to the formation of A3 plus, and therefore A3 plus, whole A3 plus is consumed by M3 plus, and we get ultimately 3H plus ion. And what is the concentration of H3A? C. So what is the concentration of at the final end of the reaction? H plus ion concentration is 3 times the concentration of H3A. So H plus ion concentration becomes 3C. So that means A, B and D, these options are correct. बेटा समझ में आया ये क्वेश्चन? थोड़ा सा टेडियस है, नेक्स्ट का ही क्वेश्चन है ये. यस, अंडरस्टूड? जस्ट प्रोसेस, एक बार प्रोसेसिंग करना. इफ यू फाइंड एनी डिफिकल्टी लेट मी नो. Okay, next is we have two sparingly soluble salts PQ and RS2. So you know PQ, so that will give PQ, RS2, that will give R2 plus and S negative, 2S negative. At 0 Kelvin, at temperature T naught, the solubility products of these two salts are found to be equal. Means solubility product of these two salts, let us say its solubility is X. Solubility of PQ is X. So KSP is X into X, that is X square. That is KSP of PQ. Solubility product of PQ and solubility product of RS2, that is equal to, let us say it is Y. So it is Y and it becomes 2Y. So R2 plus raised to power 1, Y raised to power 1 and S negative raised to power 2. So 2Y raised to power 2. So it becomes 4Y3. So KSP of PQ is equal to KSP of RS2. They are found to be equal at T naught. Now, at higher temperature T1, which is greater than T naught, the solubility of PQ becomes triple of its solubility at a T naught. So solubility of PQ becomes triple of its solubility at a T naught, and also at another temperature T2, the solubility of RS2 becomes double of its solubility at a T naught. So what is the ratio of the solubility products of PQ at T1 and RS2 at T2? So let us assume first the state, according to statement, KSP of PQ is equal to KSP of RS2 at T naught. So what is KSP of PQ? That is X square, and that is equal to 4S cube, 4Y cube, RS2, it is 4Y cube. So here this is the first relation, X square is equal to 4Y cube, or we can write X square upon Y cube, that is equal to 4. That we have predicted. Now at temperature T1, at temperature T1, at temperature T1, KSP of PQ, see, at temperature T1, solubility of PQ becomes triple of its solubility at T naught, and solubility of, it was P concentration, Q concentration at saturation point, and solubility at T naught was X. We have taken it as X. So it becomes triple. That means it is 3X into 3X, that is 9X square. Okay. Now at temperature T2, KSP of RS2. So you know RS2, that is R2 plus 2S negative. Initially it was Y and 2Y. Now it becomes double. double means now this becomes, at T naught it was y and 2y, at T2 it is 2y, so it becomes 4y, double. So R2 plus concentration raised to power 1, S negative raised to power 2, so it is 2y into 4y raised to power 2. So it becomes 32 into y raised to power 3. So this is solubility products of PQ at T1 and RS2 at T2 that we have to find out the ratio. So KSP of PQ at T1 divided by KSP of RS2 at T2, बोलो क्या हो जाएगा बेटा? It is 9x square divided by 32y cube. Now this x square upon y cube we have x square upon y cube. X square upon y cube we have calculated. Yes, x square upon y cube is equal to 4. So it is 9 into 9 upon 32 into 4. So it is 9 by 8. So answer should be 9 by 8. Understood beta? क्वेश्चन पूरा समझ में आया कैसे किया मैंने? Because first condition was that at T naught solubility products of these two salts are found to be equal. From that part we have calculated that x square upon y cube is 4. And next at temperature T1 and temperature T2 we have calculated KSP of PQ and KSP of RS2, and accordingly we have solved it. Okay. Next is the mixture of the solutions that will lead to the formation of calcium fluoride PPT is, the solubility product is given. If solubility product is given, then to get the precipitates, what is the condition? Ionic product should be greater than the solubility product. Then only precipitation takes place. So see, we have 100 ml of 2.0 into 10 raised power minus 4 molar calcium ions. It is mixed with 100 ml of 2.0 into 10 raised power minus 4 molar fluoride ion. So what is the concentration of calcium and fluoride ion? Just tell me, in the A case, what is the concentration of calcium ions? See, we have 100 ml of 2.0 into 10 raised power minus 4. But when they mixed, the volume becomes 200. 100 ml of calcium, 100 ml of fluoride. So total volume becomes 200. That means volume is doubled. So obviously concentration is halved. And in case of fluoride, it is again 100 into 2.0 into 10 raised power minus 4 divided by again 200. So it becomes 1.0 into 10 raised power minus 4 molar. So now what is ionic product? Because calcium 2 plus and fluoride So it gives CaF2. So what is ionic product? Product of the concentration of calcium ion and fluoride ion. So it becomes 10 raised per minus 4, 10 raised per minus 4 raised to power 2. So it is 10 raised per minus 12. But solubility product is 4 into 10 raised per minus 11. That means ionic product is less than solubility product. So that means solution is unsaturated. Next, 50, 100. In the second case, calcium 2 plus concentration is 50 into 2.0 into 10 raised per minus 4 divided by 150, because 50 and 100. And fluoride ion, it is 100 into 2.0 into 10 raised per minus 4 divided by again 150. So it first becomes 2 by 3 into 10 raised per minus 4 molar. Second becomes 2 by how much it becomes? 1.5. So 20 over 15. 4 by 3 into 10 raised per minus 4 molar. So what is KIP now? Two by 3 into 10 raised per minus 4 into 4 by 3 into 10 raised per minus 4 raised to power 2. 32 by 27 into 10 raised to power minus 12. Again, ionic product is less than solubility product. Third, 100 ml, 50 ml. So C option is calcium 2 plus 100 into 2.0 into 10 raised per minus 4 divided by 150. Fluoride ion is 50 into 4 by 3 into 10 raised per minus 4. It is 2 by 3 into 10 raised per minus 4. So now what is KIP? 4 by 3 into 10 raised per minus 4 multiplied by 2 by 3 into 10 raised per minus 4 raised to power 2. 16 by 27 into 10 raised to power minus 12. So obviously, even if we write 160 upon 27 into 10 raised per minus 11 molar, it is greater than 4. So what is the value? (160) it become minus 13, sorry. I took it as, so that means it is again less. KIP is less than solubility product. Now D. Calcium 2 plus concentration is 100 by again 200, 2.0 into 10 raised power minus 4, so it becomes 10 raised power minus 4 molar only. And fluoride again 100 by 200 into 6 into 10 raised power minus 3, so it becomes 3 into 10 raised power minus 3 molar. So what is KIP? Calcium 2 plus into fluoride raised to power 2 means 10 raised power minus 4 into 3 into 10 raised power minus 3 raised to power 2. So it is 9 into 10 raised to power minus 10 molar. So here ionic product is greater than solubility product, and in this case precipitation takes place. ये मैंने कंप्लीट आपको इसलिए बताया कि कैसे करना है आपको, अदरवाइज सी इंटेलिजेंट गैस कैसे लगा सकते थे आप. सी 10 रेज पर माइनस 4, 10 रेज पर माइनस 4, 10 raised per minus 4, 10 raised per minus 4 in all the cases. But in the last case, it is 10 raised per minus 2 and 10 raised per minus 3. In both the cases, concentration of calcium and fluoride ion is more. So obviously, its ionic product is greater than solubility product. So D is the right option. वो आप बिना कैलकुलेशन से you can approach this आंसर. दिस इज एन इंटेलिजेंट गैस, क्योंकि बाकी सब में था 10 रेज पर माइनस 4 मोलर. कॉन्सेंट्रेशन ज्यादा कहां थी? ओनली इन डी, बिकॉज टू गेट द प्रेसिपिटेट वी नीड हायर कॉन्सेंट्रेशन ऑफ कैल्शियम एंड फ्लोराइड आयन. सो हाईएस्ट कॉन्सेंट्रेशन इनमें सब में है, वो सब डी में ही थी. दैट्स वाई डी इज द राइट ऑप्शन. ओके हाँ, एक और मुझे बताना था थोड़ा सा आपको कि जैसे लेट अस से निकल हाइड्रोक्साइड है, ये एनसीईआरटी का ही क्वेश्चन है एक, कि लेट अस से इट्स केएसपी इज गिवन टू अस. कुछ भी वैल्यू ले लो, 10 raised to power minus 20, let us say KSP of nickel hydroxide is given to you. So question आया कि what is the solubility of nickel hydroxide? What is the solubility of nickel hydroxide in the presence of 0.1 मोलर सोडियम हाइड्रोक्साइड? ऐसा क्वेश्चन आ जाए मान लिया. सो से यू विल स्टार्ट विद, लेट अस से S is the solubility. So we have nickel hydroxide S, OH negative ion as 2S. Now when we add NaOH, we have sodium ions and hydroxide ion, and you know NaOH is a strong electrolyte, strong base. So that means nickel 2 plus ion concentration is S only, but OH negative ion concentration is 2S plus 0.1, and it is close to 0.1 because solubility is very less, because solubility product you can see it is 10 raised to power minus 20. So in such a case, you know, KSP is equal to nickel 2 plus ion concentration raised to power 1, OH negative ion concentration raised to power 2, KSP is 10 raised to power minus 20, solubility is S, and it is 2S plus 0.1 whole square, and 2s plus 0.1 is taken as 0.1 only. Always neglect the solubility in comparison to the concentration of the common ion, and that's why it is S into 0.1 raised to power 2. So S is 10 raised power minus 20 divided by 10 raised power minus 2. So it is 10 raised power minus 18 molar. That is the solubility in the presence of sodium hydroxide. Otherwise, if it is not present, then we do it like this: S into 2s square means 4s square equal to minus 20. So it becomes 4s cube equal to 10 raised power minus 20, or s cube equal to 10 raised power minus 20 by 4, and s is equal to cube root of this whole. तो हम ऐसे करेंगे इसको, ओके. बट इफ इट इज रिटर्न इन द प्रेजेंस ऑफ सम स्ट्रॉन्ग इलेक्ट्रोलाइट, तो जो कॉमन आयन है उनकी कॉन्सेंट्रेशन को ऐड करके सॉल्युबिलिटी को नेग्लेक्ट कर दें. सो दैट्स ऑल अबाउट आयनिक इक्विलिब्रियम. कोई भी डाउट होंगे तो प्लीज लेट मी नो और सेंड मी डाउट्स इफ यू हैव ऑफ एनी टॉपिक. ठीक है. नेक्स्ट चैप्टर कौन सा करना है आपको? हाँ जी, ओके, GOC. ओके, so in the next class I will inform you when I can take. so GOC स्टार्ट करेंगे, ओके. और आयनिक इक्विलिब्रियम और जो भी चैप्टर हमने किए, इलेक्ट्रोकेमिस्ट्री, केमिकल काइनेटिक्स, solve करो क्वेश्चन. if you find any doubt in those topics, do send me on WhatsApp the doubts, okay.
सर
जी बेटा.
क्लास के पहले ही आप मैसेज डाल देंगे कि क्लास है, क्योंकि आज का सुबह का क्लास मिस हो गया क्योंकि पहले आपने मैसेज नहीं डाला.
Sure, one day before I will send, okay. एक्चुअली लास्ट क्लास में वी हैव डिस्कस्ड कि अगली मॉर्निंग में क्लास होगी. एनी हाउ आई विल राइट ऑन द व्हाट्सएप, ओके. ठीक है बेटा. मैंने अगर आपको रिकॉर्डिंग देखनी होगी तो आप उसमें मैंने शेयर किया है. ठीक, ठीक है बेटा. ओके देन. ओके, वेलकम बेटा. बाय बेटा. और क्या, ਉਹ ਬੜੇ ਸਾਰੇ ਹੁੰਦੇ ਸਾਡੇ ਨਾਲ.